So here's an explanation of the homework that was assigned on either Wednesday or Thursday for Friday. Some of you are taking the practice test during class and and are watching this hopefully at home and getting ready for Monday. Some of you are watching this during class while others are taking, I said practice test, the retest of Chapter 1. Okay, so we want to supply a reason, and our list of reasons comes from reflexive, symmetric, transitive, addition, subtraction, multiplication, division, substitution, distributive, or recently we have added the segment addition postulate. So on number 12, all that's happened is that they have switched the JK to the right side and the LM to the left side. And we're going to call this, again, the symmetric property. So symmetric will be our reason here. Symmetric. The symmetric property says you can switch the sides of an equality. Okay, on our next guy, notice that AB equals, oops, don't want to do that, I can't see it anymore. That AB is equal to 14. Maybe this is what I want. Yeah. And CD is equal to 14. If two things equal the same thing, the transitive property says they equal each other. So AB is equal to CD by the transitive property. Anytime you say transitive, you could have also viewed that as a substitution. So if you said substitution, that was good also. Number 14, if W, X, and Y are collinear in that order, which means X is between W and Y, then the length of WY equals WX plus XY. Well, if you think about the segment that they have just talked about, I'll draw that down at the bottom here. They've talked about W, X, and Y in that order. So we can see that WX and XY are the two little pieces. They have to add up to the whole thing, and that's exactly what the segment addition postulate says. So here we've got for our reason on number 14 the segment addition postulate, SAP. Okay, number 15. Well, we're back to that situation where we have that PQ is occurring in both of these congruent statements. So MN is congruent to PQ, and so is RS. And so MN and RS have to be congruent to each other. So it's the same old idea if two things are equal or congruent to the same thing, then they're equal or congruent to each other. Again, that's going to be a transitive. And substitution would have worked also. All right. This one, again, is a little tougher. But if you think about what they've done here, let me erase that little diagram there. We've seen this trick before. They've taken two equations. We know that we have EF is equal to TU, and also that GH is equal to VW. And if you can see what they've done, they've just drawn a line and added them straight up, and when they've done that, that's what they've got. So, if you add equals to equals, that's just the addition property you're using. I'm going to run out of space. Addition. On our last guy, again, we'll want to notice what changed from our first equation to our second. And what changed is that JK is no longer in this equation there. It got taken away from both sides. It got subtracted from both sides. So this is the subtraction property that says you can do that. Okay, we had one little proof to do. It was number 12. Got this over on the next page, and I've started off by writing the given down as the first step. I'm going to mark on the diagram what we know. Segment AP is congruent to segment PC. And segment BP is congruent to segment PD. Well, all we're trying to show is these longer segments, namely AB and CD are equal. Well, they're made up of parts that are equal, so they have to be. And that's what we're going to try to do. What we're going to do, it's a segment proof. We have very little to work with. We're going to try to work that segment addition postulate in here to get us started. And for the yellow segment, AB, it would say that AP plus BP equals AB. We can also make the same statement for the red segment, CD, that CP plus DP equals the whole deal, which is CD. Now, both of those are made by using the segment addition postulate. Okay, it would be great if we could get AB and CD into the same equation somehow, and I'm pretty sure that we'll be able to find a reason here. Well, it's going to be a little tougher, actually. You might remember, let's see if we can go back to this frame back here, that on problem number 16, highlight that in something if I can get the highlighter going here. Highlight it in yellow. On 16, we used this little trick where we took two equations and added them straight down to make a new equation. That's what we're going to do on this guy. We're going to take what we see in number 1, and we're going to treat it like it says equals instead of congruent, because I've given you the right to do that. And if we do that and we add the ones I'm boxing in yellow here, if I add straight down, what I will get is that AP, this will be step 3, AP plus BP equals CP plus DP. And since I added equations straight down to get that, this is simply the addition property. Okay, we're almost done. Now, we would like to have AB equals CD, because that's the same thing as saying they're congruent. And if you look, the left side of equation number 3 has AP plus BP in it. Okay? Statement number 2 says that AP plus BP equals AB. So I can put AB in its place. That's a substitution. On the right side of statement number 3, we have CP plus DP. And if we look at statement number 2, it says that CD equals CP plus DP. So again, we make another substitution. And I've said to you, if you want to change from congruent to equals or equals to congruent, you can just write it down and not have to add another step. So this is the same as AB congruent to CD. That's what we're trying to prove, and we're all done. Check Prism for some homework problems over the weekend to have ready for Monday. Just some more of these fun proofs.